Are you ready to start this one?
Yes.
Now, are we going to need to sub some things in to figure out what our proposition looks like, essentially? Because again, at the moment, we just have this summation, don't we? So, what's our first one going to be if we're subbing 1 in? So if we're subbing 1 into this, what are we going to get?
1.
Well, we're going to have, if it's 1, I'm going to get 1, 1 plus 1, which is equal to 2, right? What about if it's 2? 6? What if it's 3? And I think you probably only need to go that far. Yeah? So if we do our first step straight away, what was our first step again? Yeah. So not quite, we need to do the proposition step or the conjecture step, which is Pn is. So we're going to go 2, not comma, 2 plus 6 plus 12 plus. Now we're going to change, wherever there's an I in here, we need to change it to an N. So it'll be n plus 1 is equal to what we've got there. And we also need to try and get into the habit of writing for all n within the positive integers. Okay, we're right with that part. Now we're going to go to Javaja's step, which is our basis. You don't need to write basis if you don't want to. You could just go straight into if. So if n is equal to 1. So if n is equal to 1, what's our left-hand side equal to?
2.
2. Good, because remember, n is equal to 1 is the first term. So our left-hand side is equal to 2. What's our next step of that?
Right-hand side.
Yeah, so right-hand side. So what are we going to sub in for n in that case?
n plus 1.
So what are we putting in for the n though?
1.
1. Good, I'm just checking because now that we've just found that the left-hand side is 2, I can just imagine you'll get on that roll and you'll sub 2's in instead of 1s. So 1 plus 1, 1 plus 2, 3, should be equal to, 6 on 3, should be equal to 2. We okay with that? We can see that that's 6 on 3 on the top.
What happens if they're not equal? Or will they just be always equal?
If they're not equal, then your whole process won't work. So you could say that your proposition is not right. However, I would say in this case, if you're getting that, double check everything. Because at the moment, they should all work.
Yeah.
I was going to say why is it 6, and then realised I was doing 1 plus 1 equals 1.
It's okay, we've all been there. So therefore, we can say P1 is, I'm not writing very well on here, is true. Yeah? What was our third step? PK. So we say if PK is true, because remember at this stage we're assuming it's true. PK is true, we're going to have, what do we got? 2 plus 6 plus 12. And what do we do with that last term?
K plus 1.
Yep, perfect. So we change the n to k's. And what about on the right hand side?
K plus 1, K plus 2.
Love it. Okay. Now let's look at the PK plus 1 scenario. So this is kind of like our fourth step now. So we're going to have 2 plus 6 plus 12 plus K plus 1. Now I think it's always important to, actually I'll wait for you guys to write that down, but I think it's always important to still show this K step like you've got up here. You might see in other videos or textbooks or other things where they just ignore that K and then they just show you the K plus 1 step, and then it's harder to see that you can actually sub in for it. So I think it's always important to basically just write out the exact same thing you've got above, but add the K plus 1. So,
And is it all in brackets and then plus another one?
yep, so what's our next one? Oh yeah, you want to put brackets in here?
Oh, yeah.
And then K
Probably
plus
don't
1.
need to because they're
Yeah.
timed.
Yeah.
Times. So what's our next step?
It would be
Isn't it
K
just
plus
that
1
term plus
multiplied by K plus 1 plus 1.
Yep, so K plus 1 and k plus 1. Let's put that in brackets, plus 1. Are you happy with that? Yeah, so you could change that and you could just go k plus 2 if you wanted to. Yep, what's the end going to become here? Like, or the, sorry, I shouldn't say the end, the right-hand side.
It's gonna get so long.
K plus 2. Oh no.
Oh, yeah,
It's gonna take a long time.
No, so let's think about each of these k's. These need to become k plus 1, don't they?
Oh, just K plus 1.
Just k plus 1, because that's all we're doing. Remember, we're just going to the k plus 1 version. So all of those k's need to become k plus 1. So,
It could be K plus 1 plus 1 plus K plus
so couldn't we say k plus 1? Then couldn't we just go k plus 2? K plus 3? We okay with that? Or do we need to see the other step? Does that make sense?
Yes,
Yeah, because this one here is technically k plus 1 plus 1, which is equal to k plus 2. And then the same process applies here where you've got k plus 1 plus 2, which is equal to k plus 3. All right, so we're okay with that. So let's go to the left-hand side. So what is our left-hand side going to be equal to?
The right hand side.
Well, that's what we're trying to show. But we've got to make sure we can show that.
It's gonna equal PK because like the
So remembering that we're going to sub this. So we've got this bit here, which is the same as this bit here. So we're going to sub this bit in here. So that bit now is going to come down to the start of our left-hand side because they're equal, right? Once we see that a few more times, you'll be like, oh yeah, I know how to do that. That's simple. So we're going to have k plus 1, k plus 2 over 3. And then we still need to remember, I might just erase. We still need to remember to add in this last little bit, okay? Because we didn't sub in for that. So you still got to remember your last term, which is plus k plus 1, k plus 1 plus 1. But we could have written that as k plus 2, which we'll do shortly. Okay, now what are we going to do?
make
Same comment, yeah.
Yep, so can we, are you guys okay with if I just change this bit here to k plus 2? We're okay with that? Okay. That looks like a H over here. That's terrible. That is a 1. I can't... Anyway, we know that's a plus 1. Okay. What are we going to need to times by? 3 on 3. I love it. We will need to times by 3 on 3 for that second one. Now, I'll show that step again. So k plus 1, k plus 2 over 3 plus 3 lots of k plus 1, k plus 2 on 3. Are you okay with that? Don't forget that 3 on the top line. Okay. Now, if at any point you guys are like, oh, I've got this, and you want to go and finish off this question and not listen to me, that is fine. If you think you've got it. We're happy to move on to the next step. So we're going to have k plus 1, k plus 2, plus 3, k plus 1, k plus 2, all over 3. What are we going to do next?
Can you take out
Take out the k plus 2.
You can take out 2 common factors. What common factors?
K plus 1 and K plus 2 you take out. And then it becomes K plus 2. Oh, yay.
Woo! Exactly what happens. So if people can't quite see that, we're pulling out this k plus 1 as a common factor, the k plus 2 as a common factor, and we've got what we've got left is this k and plus 3, which formulates this bit here. And have we now just equaled this to the right hand side? Woo! We did it. What's the last thing we need to do?
Oh, write a sentence.
Write that wonderful sentence. So since
Since P1 is true.
1 is true,
1 is true.
1 is true whenever
I'm going to write that sentence every time.
PK is true. Yep. PN, which remember PN is that proposition we said at the top. PN is true for all n within Z. And then we can say PMI.
Do we get a cheat sheet for this test?
Hasn't been discussed yet.
Well, you had the one
It
without a
said
cheat sheet.
It won't be a non-calculator test, would it now?
I would say you should have one, yeah, because we've already done our non-calculator and non-notes. But, you know, we could make it interesting. Do we feel better now that we've seen those two? Do you guys want to have a go at C by yourselves?
Yeah.
And then I might do the solution slowly.
Yeah, when you do the when you group the factors like the second to last step.
Yep.
I thought you'd get like 2 lots of k plus 2. But
No, because you're pulling it out. It's like, I think it works well, like I was saying to Ella before. If we imagine that this is kxy plus 3xy, where we'd pull out xy as a common factor and we'd be left with k plus 3.
oh
Yep. So that's the same that this is x here, and then this is y.
Yeah, that's
Does that help? Hi, Kai. That's all right. Ella, did you say you had a question?
Yeah, when you for all negative integers, instead of like all the pluses, would it just be like 1, take 2, take 3?
Yeah, you'd be looking at -1. Starting at -1, yeah.
For when it's negative.
So instead of P1, you'd be looking at P -1. But I don't think we're going to see that. All right.